Welcome at the new vlog meetup. Today Goffert will talk, it's all about blockchain and especially about the maximal extractable value. I'm really excited to hear more about it, and I hope you too. So Goffert.
Okay, welcome everyone. As Casper mentioned, I will be talking about MEV today, which stands for maximally extractable value, or minor extractable value, which is the old term for this. It's a talk mostly focused around Ethereum, but it sort of generally applies to any kind of smart contract blockchain. So a little bit about me. I'm Goffert van Gool. You can see my contact stuff up there. People tell me sometimes that I'm a guy that knows things about stuff, but other than that, nothing too special. So today, I know it's a blockchain talk, and usually it attracts a certain crowd. It generally attracts a type of people that would like to learn more about making money or getting rich really fast. So if you're hoping that I'm going to show you how to make money, you're going to be disappointed. Today I'm only going to be showing you how to lose money, but at least you'll learn something. So that's the goal. I'm going to go over a number of different topics, and some of them may be a little bit complex, but if you have any questions, please feel free to just interrupt, raise your hand, and there's always room for questions. I have a lot of room spare to answer lots of questions, so feel free to ask if you want to know something. Okay, so we're going to begin with a little bit of economy, because everything revolves around economy. And specifically, I'm going to be talking about the term of economic efficiency. So economic efficiency is a term where resources in a system, an economic system, are distributed optimally, where you cannot move resources around or allocate them differently, that someone will be worse off. Another way to describe it, which I think is more intuitive, is that products are priced in an optimal way. So that means that every product has the price or the cost of its actual sort of intrinsic cost to produce, or the value that it creates. But if you change the cost of things, then things sort of get out of whack. And one of the things is that large systems, if you have a large economic system, this sort of inefficiency is unavoidable. There's always some way that you can sort of extract value from a system like that. It's because you cannot know, if you have to price everything perfectly, you would have to have perfect information about everything, all the costs of everything, the price of every item in every location. You simply can't do that. So when you price items, you sort of have to guess what you think is appropriate price, but it may not be the optimal price. So when you think about this economic inefficiency, that seems like it's sort of a bad thing, but it's not really necessarily bad, because if you think about it, economic inefficiency creates room for entrepreneurship, because basically what an entrepreneur does is they take this inefficiency and extract it with the business. So a simple example is, if you figure out that the price of flour and water and labor is lower than the price of bread, then you can start a bakery, and you can sort of make this value or price difference, you can extract that from the system by producing bread. Or if bananas in Honduras are 1 cent, and the cost of transporting bananas to Europe is 50 cents, and you can sell bananas in Europe for €1, then you can start a banana importing business and bring bananas from Honduras to Europe and extract money that way. So any kind of economic inefficiency that exists in a system essentially makes it so that someone can turn that into a business. And Ethereum is such a large economic system. So the amount of economic volume of transactions, or just the economic size of the Ethereum network, is incredibly large. The latest research pointed out that there's like $6.2 trillion of value settled per year on the Ethereum network. And that probably does not include a lot of items. It just includes the price of Ether, the base currency, and some stable coins. But of course, there's a lot of other valuable objects on the Ethereum network that are being transferred that are not accounted in here. So the Ethereum network naturally also has this sort of economic inefficiency, that there are things that don't have necessarily the correct price, or there are economic inefficiencies. So as a test, what we're going to do is we're going to introduce some of this economic inefficiency in the network and then see what happens. So what we're going to do exactly is we are going to deploy a smart contract. Maybe I should increase the size. So this is a simple smart contract that we are going to deploy on the Ethereum network. And basically what this contract does is nothing but allow anyone to take all the money in the contract. So I'm going to deploy this contract with some money in it. And it's essentially the same as putting some money on the street for anyone to pick up. So this is sort of an inefficiency that anyone can just take. So let's see what happens if we do this.
What language is this actually?
This language, so someone asked what language this is. The language of this is Solidity, which is the sort of default programming language for smart contracts on Ethereum. So we're going to have to figure out how to do this. I'm going to put 20 Finney, so this is 0.02 ETH on the blockchain and the smart contract. Let's see if everything's correct. It looks like it. Okay, so I'm going to deploy this contract now. So basically, at some point, this contract will land on the blockchain, and then there's 20, so 0.02 ETH for anyone to take. Anyone can just take this money now. So the real question is like, what is going to happen? So I wonder if anyone here has an idea. What is going to happen to this contract? Does anyone know? Does anyone have any ideas? Okay, someone here has an idea. What do you think is going to happen?
I already know.
Okay. Yeah. Okay. Does anyone have an idea? What's going to happen when I put this contract on the blockchain? Yeah. Okay. So it. Yeah. So it's going to deploy it, and then someone will have to call the take function. But do you think someone will call this?
You can find it.
Okay. Yeah. So Willem says that it's going to be difficult to find. So we're going to see what happens. Let's check if it actually got deployed yet. It looks like it did. Okay. Okay, so the contract was deployed. And now there's some free money somewhere, so we can take a look here. If we go to Etherscan, you can see here that we now have this contract deployed. But yeah, it doesn't look like anything is doing anything or anything is happening. So let's take a look at why this may be the case. All right. So when we deployed this contract, what we did is just put this contract on the blockchain, but someone still has to interact with it. Someone has to make a transaction to actually steal this money, and or steal, take the money. It's anyone can take it. It's not being stolen. So in order to understand the next bit, we have to talk a little bit about something called the mempool. So the mempool is a name for, in blockchain it's a common term. It's a name for all the transactions that are sort of pending. So when you make a transaction, or when you want to make a transaction on Ethereum, for example, or on Bitcoin, what you do is you broadcast, or you send this transaction to the mempool, but the transaction doesn't actually happen immediately. It needs to be included into a block before it actually has been processed by the blockchain. Until then, it just waits in this sort of waiting list for it to be included. And of course, this list is publicly visible. Anyone who has a node on the network can see all the transactions in this pool. So anyone is able to see all the transactions that are going to happen sometime in the future. And essentially, when you make a transaction on the blockchain, what you do is you signal intent. You're actually saying like, okay, I want to make this transaction. Here is the transaction with my signature, and you put a fee with the transaction, hoping that someone will mine a block and put your transaction in it. So the people who actually make the blockchain, or who create the blocks and put transactions in them, are the miners. And what miners do is they look at the mempool, so they look at all the transactions that are waiting, they take the ones that are most profitable to them and put them in blocks. And transactions that are most profitable to them, of course, are the ones that pay a lot of fees. So when you pay transaction fees, essentially most of these fees go toward the miner. And the reason that fees are high is because everyone is trying to get included into a block, so they have to be the most attractive sort of a transaction for miners to pick up, which you do by having a high fee. So the question is, don't you need some kind of service or app to look into the mempool? I thought only the miners see the mempool directly and the rest can glimpse through something. So the mempool is not something, you need some kind of software, but essentially when you have a node, so an Ethereum node or a Bitcoin node, or most cryptocurrencies have this sort of concept, all the nodes in the network share this list of pending transactions, and they send them to each other. So the nodes sort of create this list together, and it's a peer-to-peer network. You can think of it like BitTorrent, except instead of sharing video files or whatever, they share these pending transactions so that everyone knows about them. And if you want to look at them, you will need some kind of specialized software to inspect it. But I think there's also websites that you can use to inspect the mempool. For example, if I just type in mempool, we will go to mempool space, which is a mempool explorer for Bitcoin. And here you should be able to see, I'm not sure if you can see the actual transactions in the mempool, maybe somewhere, but this will give you some insight into how many transactions are in the mempool currently, how many fees they're willing to pay, and all sorts of information like that. So there are some tools like this that allow you to inspect the mempool for several blockchains. Right, so to return to our question, what happens when we create economic efficiency? The answer was already sort of given, but it is indeed, it looks like nothing happened. Let's refresh the page. And yeah, this contract is still here. Nobody took the money yet. So the answer is nothing. Nothing happens. And someone here had a good idea. The reason why nothing happens is because it's really difficult to tell what this does. If I go and look at the contract, this is the actual code that people see, or that people can see. When they see that I deploy this contract, they see this bytecode, and this is essentially what it does. And from this, it's really difficult to tell what this does. Nobody really knows. You could probably make some kind of software that can decode this and actually figure out what contracts do. But it looks like nobody's actually doing that, because if someone was doing that, they would probably have taken the money by now. So let's go into the next step.
Maybe it's too little money for it.
Maybe it's too little money for it to be worth. That's a good question. So nobody took it, but maybe we just have to sort of give people a hint what this contract actually does. So what's going to happen when we try and take advantage of this money? So now what we're going to do is we're going to try to actually take the money from the contract. So we're going to call the take function, and we are going to try and take the money. Let's see. Let's try and take my money back. This is an expensive demo for my employer. I'm going to bump the gas limit up a little bit just to make sure. And the max fee seems fine. So this is a live demo. I don't know if this is going to work, but let's just see. We're going to confirm. So now we send a transaction into the mempool that is going to call this take function in our smart contract and try to take this money. Hopefully, because this is a live demo, you never know, but hopefully someone will see this transaction and will notice that hey, someone is trying to call this function and they just get money. Maybe if I call this function, I will get the money instead. And if they are smart about it and fast about it, they can actually do this, and they can sort of steal the money that I have. So now you can see that my transaction is in the mempool. So you can see this is the transaction I created, which is a pending transaction. And at some point, this will be included in the block. But my expectation or my hope is that someone will actually see this transaction in the mempool now and then front run me. So they are going to submit a transaction that is also going to take this money, and they are just going to make the fee slightly higher. And what will happen is that their transaction will be in the mempool the same as mine, but because they pay a higher fee, the miners will take that transaction before they take mine. So their transaction will go in first, and they will take all the money, and I will be left with nothing. But it looks like we have to wait a little bit. Okay, so while we're waiting, this is so this phenomenon of people looking at all the pending transactions and just sort of stealing or trying to steal the transactions that create any value like that is something that people have been looking into in Ethereum for quite a while. And at some point, the name of the Dark Forest appeared. So this is from a novel. And the premise of this novel is that there's some kind of advanced civilization that is technologically way beyond the people of Earth. And the only way that they can survive is to not be detected, because if anyone is detected by this civilization, they will certainly die. So the whole point of the book is to sort of try and avoid being detected. And the same thing sort of applies to Ethereum here. If the moment that you step into the mempool and publish your transaction, you're basically walking out in the open, and anyone can see what you're trying to do. And at that point, you're extremely vulnerable, and anyone can sort of exploit whatever it is that you're trying to do. And by day, of course, the technologically advanced enemy here is robots. So what people did is they created all sorts of bots that just scan through the mempool and look at transactions that are submitted all the time, and then try to exploit them. So what they do is they just sort of look at the transaction and see what happens if they were to run the transaction instead. or what would happen if they changed some addresses in a transaction. Maybe there's some things about the transaction they can change that turn the transaction into a profitable transaction for them. And the only thing they have to do is if they find that the transaction is more profitable, if they change it, they can just submit the same transaction but with a slightly higher fee, so that the miner will take their transaction instead of ours.
How much is normally the fee?
So question was just asked, what is normally the fee? So the transactions we just made, let's see if they completed. We can see the fee for the transactions we did. Our transaction is still pending. Did we not pay enough gas? Yeah, so this is the transaction we just tried to do. Oh, did we set no gas fee? Yeah, maybe that's an issue. Let's try to actually set the gas fee here. Yeah, so this state transaction is costing $17 now for me to submit. So let's try that. So now I'm going to resubmit my own transaction with a slightly higher fee in hopes that someone picks it up. And that it's going to complete at some point. But I have no idea what's going to happen.
Transaction with no fee?
What?
What happens with a transaction
If
the fee is too low? Stays it there forever?
Yeah, but usually nodes have. So the question is, what happens if you put a low fee or no fee with a transaction? So the mempool or the space that the nodes maintain, they will just evict it at some point. So they maintain a list, and only maybe the top million most paying transactions are relevant to keep. The other ones they just drop. So eventually your transaction will just be dropped from the list. It looks like. Okay, so here. It looks like our transaction completed here. So we called this transaction. This is the transaction I just submitted. I called the transaction, but we see that there's a value of 0 Ether. So what happened? The balance of the contract is gone. So the money that was in there is gone. So what gives? Why didn't they take the money? Well, it turns out if we look at internal transactions, there's a bot address that actually called the transaction right as I submitted it now, just 50 seconds ago, and took the money. So this is the thing that I was hoping to demo. And yeah, so it turns out if you try to make any kind of transaction, and then even if you make a little bit of profit, so the transaction fee here was $17 or something, and I would get something like 70, so there's like a $50 sort of free money. Someone had this program that found my transaction and front run me.
How much money is on the contract of that bot now?
Yeah, that's it. That's a good question. This guy currently has a balance of 79 ETH. But we will get to that later.
But how much fee does he pay? Can you see that?
How much fee did he pay? Yeah, that's kind of complicated to see because these bots use sort of advanced systems. They use other smart contracts, so they don't make the transaction itself. They have another smart contract that makes a transaction for them, and sorts of tricks that they can use to. But I'm not going to go into that. So this seems like a sort of a novel or a weird thing, but actually this is a very this is something that is not super new. So this book arrived a while ago. It's called Flashbots, and it described the change that happened on the stock market due to high frequency trading. So high frequency trading is sort of the same concept as this, but then applied to the stock market. So what high frequency traders do is they try to get their orders in the stock market as fast as possible, so that when there's any kind of market movement, they are just the first ones to execute their order. And there's all sorts of other exploits that they can do simply because they are faster than everyone else. When there's any kind of economic inefficiency in the stock market, which can happen the same way as it can on Ethereum, high frequency traders exploit that by just making sure that their transaction or their exchange happens faster than anyone else's. But the key difference here between this and the stock market is that on the stock market, high frequency trading, the thing that matters is speed. When you have a faster connection to the exchange, you can make your transactions happen faster. But on Ethereum and other blockchains, you cannot. The only way you can go faster is by paying more money to the miners. So essentially, it's an auction system. When someone auctions free money, so what I just did, I essentially just auctioned $70, and anyone can pay any amount they want, and the highest bidder gets the $70. So the natural behavior here is that people start outbidding each other, and this is actually what you see. There's been a lot of research on this topic, and it turns out that when there's certain profitable transactions, that you'll have multiple bots actually outbid each other and trying to be the one that wins the transaction. So here we see this sort of chain of bids, where on the left was when the first transaction was submitted, and then the triangle and the circle are two different bots that are submitting the same transaction with little increases in fee, hoping that their one will be the one that's going to be picked up by the miner. And naturally, this sort of bidding, how much money would you be willing to bid to get $10? Realistically, the answer is $9.99 or something like that. So the fee just keeps increasing up to the value of the transaction. So in the end, most of the value that is unlocked here actually goes to the miners, because the bots that are competing against each other to take this free value have to outbid each other to be included into a block by miners, and they will be willing to pay these fees that are close to the actual value of the transaction that they can capture. So this is why the MEV term was coined. Essentially, all this extra value that is available will eventually end up into pockets of miners, because if the automated systems are advanced enough to play economically in a rational way, they will just keep outbidding each other until the price matches or nearly matches the price of the value that is available to take, and then the fee will go to the miner. So on the Ethereum network, so this is binary extractable value, but recently the term maximally extractable value has become more popular because not all blockchains have miners, and there are other things that sort of change this balance a little bit, and this is a more appropriate term to use these days, but they refer to the same thing. And if we look at Ethereum, the amount of extracted MEV over the last 2 years has literally exploded. Since January 1st, 2020, almost $1 billion have been unlocked using methods like this. So this is essentially all money that comes from transactions that are inserted before other transactions, or other tricks that are used by people who are trying to extract this value. And this is a low estimate, so this would be things that are actually measured, but there are a lot of ways that people are extracting value that are almost impossible to track. So there's probably a lot more value than this. The problem with this is that there are a lot of negative externalities. So one of them we've already seen. If you make a mistake, or if you happen to drop some money like I did, it becomes almost impossible to extract it again. So if at any point this sort of inefficiency arises, it's almost impossible to get out, because once it's there, the only way to take it back is to make a transaction, and then the moment you try to take it out, someone else will notice, and then you get this problem where they will just front run. And other problems are that you get people who are trying to front run trades. So let's say you go to a market and you try to buy some eggs, but right when you try to buy them, someone quickly comes and buys all the eggs and doubles the price. that would be a really awkward experience, but this is actually something that happens on the Ethereum mainnet right now. So if you make a large exchange on a decentralized exchange and you exchange a lot of value between two coins, what someone will do is they will sandwich your trade and make sure that right before your trade goes in, they will buy a lot of things, pushing the price up for you, and then you will buy at a higher price. And then right after, they will immediately sell again and be able to sell at the price that was bumped up because of your high purchase. So they essentially make every purchase a little bit more expensive for you if you are a lucrative enough target. And there's all sorts of other issues with it because it creates all sorts of instability for the network itself, because the miner rewards become really unpredictable, and this sort of creates the wrong incentives for miners because they may be incentivized to mine different blocks or do things that sort of destabilize the network. So on Ethereum, there's an initiative that is trying to solve this problem, and it's called Flashbots. So Flashbots is an initiative of people who are trying to work on tools for all sorts of things that are related to this, but the core essence is that they are trying to create sort of a tooling infrastructure that you can use to submit transactions directly to miners. So you sort of bypass the mempool and in a way make your transactions invisible to others. And initially, of course, this is very lucrative for people who are trying to exploit these types of things. So I'm not sure, maybe I can check. I don't think the transaction that took our money was made through Flashbots, but it may have been. So this transaction, no, this is just a regular transaction. But if you make a transaction to Flashbots, what you do is essentially you make a little bundle of transactions, and inside that you make a payment to a miner directly, and then you send that bundle to a miner, and then if they include it in their block, then essentially you pay them directly. So instead of paying through Ethereum and the fee system, you sort of bypass that and just pay a miner directly in some ETH if they are willing to include the bundle in their block. So this is something that initially is very lucrative for people who are trying to extract MEV, because they are the ones that benefit from being able to do these things in sort of a sneaky way. They don't have to outbid each other anymore. And then the person who just has the best price the best price estimate can win the transaction. So if you feel like there's some value to be captured, and you estimate that you're willing to pay $50 to capture that value, and you are the person that has the best price estimate, then you can get your transaction through and actually take the value. So Will Schiller asked, what about mining your own transaction? That is, of course, an alternative. So if you have your own miner, you can just mine your own transactions on your own node. The issue of that, of course, would be that you would have to have a lot of mining power in order to do that, because unless you're willing to wait a long time until you mine a block. But generally, for individual users, it's almost impossible to ever mine an Ethereum block on their own at this stage. So it's not really feasible unless you are a large miner. But this is essentially what Flashbots is allowing people to do. So they allow you to use the mining infrastructure of miners, and you essentially just bribe them and say like, hey, can you mine this transaction for me? But you are correct that you can theoretically also mine your own blocks. So miners also have somewhat of an advantage in this game. If miners do this, they have the advantage that of course, they can just control everything. So they can just decide where to put every transaction and make sure that they get the most value. But Flashbots is trying to sort of create an ecosystem where the mempool is less important, and that it becomes possible to make Ethereum transactions without the mempool. So also as a user, you will be able to submit transactions to miners directly, and thus avoid being front run. So that if you make like a large trade, or if you found some money on the street and you want to pick it up, you can actually do it without the fear that someone else finds you and then takes your money. Yeah, and like an example is that a good example is this guy. This guy is known as MEV Alpha Leaks. He is a someone who writes bots to do this value extraction, and starting from literal no money. So the first transaction he made was something to exploit money, and using that money he deployed a smart contract that he used to exploit it. So he literally starts from nothing, and he made about $500,000 in 25 days by doing the exact same thing that just happened to our transaction, but in a lot more clever ways. And the interesting part is that they open source all the tools and things they create. So he produced a lot of innovative techniques to just be able to extract more value, basically. If you're interested in this space, you should follow this guy. So I kind of lied. I'm actually telling you how to make money. Is follow this guy and also work in this industry. I think he stopped at some point because he made enough money that he's not interested anymore. But he's still in the space trying to develop tools and generally improve this ecosystem. But yeah, that's basically it. So what I would recommend is, if you're interested in doing this, read more. All the people who are working on this are communicating here. This Discord is really cool. People are talking all the time about how they can extract more value or innovative ways to extract value. It is very competitive, so if you want to be successful here, you need to be very smart, because there's a lot of smart people who are trying to do this, and you have to be a little bit smarter than them. Otherwise, they're going to take the money and you're not. So the best way to, there's a lot of different strategies. You can go for high value things, but then you have to be the very first person to find it, and nobody else knows about it. Maybe if you can find something like that, you can take a lot of value. Other ways are also taking like less lucrative targets that nobody's interested in. So maybe you can find like a lot of places where there's like a little value all the time, and you just extract like $5 at a time, but you can do it at a higher volume. There's a lot of different strategies, but all these things are discussed here. So if you're interested in that, then I recommend you take a look. But that's basically it for the talk. So does anyone have any questions? There's time for Q&A. Willem has a question.
Would you consider this as illegal?
Okay, so the question is, would you consider this illegal? The answer is no, because there is no concept of legal or illegal. On a blockchain, you're just making a transaction, and how do you know? There's no like, so the old saying is like the code is law. This is kind of a weird saying, but essentially when you make a transaction, you can do whatever you can with that transaction. There's no kind of law telling you what transactions you can and can't make. The transaction you can make is the one that the program allows you to do. So if you can make a transaction that takes some money from somewhere, then you can. The question is if it's ethical. And there's a lot of difficulty. So there is actually some precedent where someone managed to hack some important smart contract that held like hundreds of millions of dollars like it was some decentralized finance product. So there's a lot of people who had like savings or other things in there. Someone managed to hack this, and then they tried to take all that money, but they got front-run by someone. So someone else saw the hacker's transaction, and then they took the money instead. and the person who did the front running returned most of the money back to the original owner. So it really depends. Like, there's no clear side of like, okay, people who do this are wrong, people who do this are right. There's of course some kind of morality involved in everything. You said the initial transaction code was not recognized by bots, so how is the take transaction recognized? Yeah, there's a difference. So the initial transaction was the deployment of the contract. So the contract that is now on Ethereum is just some code that anyone can execute. The problem is that no one knows what it does. It's really difficult to tell, given if you don't have the code for the contract, but you only have the deployed bytecode. You can't really see what will happen when you interact with the contract. But if I make a transaction, it's really easy to take that transaction and just run it yourself and then see what happens. You can just sort of emulate it. So you can, if you have your own node, you can just make your node mine a block because you can decide the rules for your own node. You can just make your own node mine a block with your transaction in it. And then you can see the result, right? You just don't broadcast a block, so it's like a private node. But you can simulate this transaction, and because you can easily, that way run all the transactions that other people are trying to submit, but run it yourself or maybe change some things about it, and you can just sort of test run it. Because I gave the hint how to interact with the contract by putting my transaction in the mempool. Other people can just copy it, basically. So that's the difference there. Geert asks, any idea how competitive MEV is on less populated blockchains, for example, Solana or Cardano? This is a very underexplored area. So it took Ethereum a long time to even get to this concept. So Ethereum is like, what, 8-9 years old at this point. But MEV, as we saw in the graph earlier, MEV extraction really started around 2020, which is just 2 years ago. So it took a long time for this sort of ecosystem to evolve into a state where these types of things are happening. I don't know how developed other smart contract ecosystems are. But it's an interesting area. So probably there's a lot of money to be made there. If you are one of the first people to get to a high level of sophistication on those networks, you can probably extract quite a lot of value there. Next question, can you hack people by making fake transactions that execute some virus? No, you cannot. So it's an interesting trick, because basically what you're doing is you're going to send a transaction that screws someone else over, and then if they run it, and then you hope that the bots will try to run the same transaction and then break their stuff. But it doesn't work, because every transaction runs inside the Ethereum network itself. So the Ethereum virtual machine simulates what will happen to the transaction, and there's just an outcome. At some point the transaction ends, and then you can just see what happened. So how much money moved where. And so someone else who's copying your transaction will just run that transaction in their test environment and see what happens, where the money goes. And at the end, they evaluate, is this something I want to do or not? And if it would be something that they lose money on, they won't do it. But I have to add that in the past it has been done. So there was someone who was trying to trap people who tried to do this. So there were sort of really basic bots that were trying to extract value, and mostly in the area of front running on exchanges. So when someone makes a big trade, then I'm going to try and get my trades around him to sort of make him pay more and take the difference myself. If you know that a bot is going to do that, and the bot is not very sophisticated, then you can exploit that. And someone actually managed to do that, and then they would just target these bots and drain all their money, because once you target the bot and say, hey, this bot has 70 ETH, I'm just going to run transactions until yeah, I took all his ETH and he can't do it anymore. And there's all sorts of blogs of people who did this. So there's like a blog of someone who made like a few $100,000 just stealing it from these bots. But obviously people quickly adapt. So once they notice that their bots are losing money, they will change their code, and so they don't fall for the trap again. So you have to find some kind of new innovative way to trap them. But it is theoretically possible.
Did you try yourself to do things with this kind of stuff, like exploiting those?
Okay, so the question is, did I try it myself? No, I only tried to lose money successfully. I didn't try to take money, but the interesting part is that if you go on their website, they actually have example bots. So they have GitHub repositories where there's the bot ready. You can just fork the repo and just change some parameters and say like, okay, I want to target this exchange or this contract. And then you can run it, and then it will probably make some money.
Okay.
But it will make very little money because everyone is running that same one because it's a basic example. But yeah, you could. The level 2 entry is quite low if you have some technical sophistication,
Okay.
and you can just toy with this at home, definitely. The question is, so the MEV bots hold the money in some way? I thought you just send it to your wallet. And how would anyone use a bot to get money? Yeah, so the most of these bots work through contracts. So we saw here that these MEV bots are actually smart contracts. So they have a program that makes a transaction, but they don't make the same transaction that I did. Instead, they make a transaction to this smart contract, and the smart contract then has some additional logic and rules to make the original transaction and take the money, and the money ends up in the smart contract. Let me. I need to find this guy. Yes. So this is one of those bots, and the smart contract this smart contract holds 40 Ether. And the reason why they use these bots is because there's all sorts of reasons that, and it's all. It's all related to how much gas it uses to make a transaction. So if I make a transaction from my address, it's going to change a lot of balances and things. And specifically, creating a new balance or doing these types of things costs a lot of gas. But if you have a smart contract can call another function in a way that is much more gas efficient. And one of the things you see, for example, is that these contracts all start with a lot of zeros. And the reason why that is because if you have to send an address as an argument, you don't have to add the leading zeros. So this is saving some bytes because they have to, their call will be a little bit shorter because when they add their address, it has fewer bytes in it. And that saves some gas, and that allows them to make the transactions cheaper. So the reason why people use these types of contracts is just so that their transactions are cheaper, and they can take the money with less overhead, essentially.
Those contractions are kind of proxies for
Yes.
them to get it faster in the network.
Yes, exactly. So this is like a proxy that they use to make their transactions. So instead of submitting the transactions on their own, they have this thing do it. So you can see this is the actual address of the owner of the bot, and they make a transaction to this thing. So they can see here, for example, this transaction was reverted, but let's look at the one that worked. So this is a transaction that someone made. So they make this transaction with this data to this contract, and then the contract will, so in this data is encoded the actual transaction that they have to do. So where am I going to, what am I going to call, what other contracts am I going to do? And in this case, this transaction is to just swap some money for LDO on SushiSwap, and then swap the LDO back to Ether on Uniswap. So just exploit the difference in price on two exchanges. And then they just pocket the difference, which in this case is a significant amount of money.
Probably this transaction is also
Yeah,
made by another bot.
No, so this is a Flashbots transaction, and you can see that because they also transferred some significant amount of money. So this is 0.6 Ether, which is like $2,000. and they transfer it to Beeple, which is the miner of this transaction. So this transaction bundle basically has a bunch of logic, which includes the part that extracts the value, and also some fee to tip off the miner to include this transaction in the block. And he paid 0.6, so probably this transaction was worth maybe 1,000, 2,000 profit for the creator of this bot. And yeah, so the next question, how competitive is the Ethereum MEV right now? Probably quite competitive, but as I mentioned, there's a lot of ways to start. There's not a lot of players in the market. Probably you will not be able to make 500,000 in 25 days. But you can probably make some money if you have enough programming experience, if you have enough experience with Ethereum, understanding smart contracts, if you have a lot of understanding about decentralized finance and the contracts that exist and how to exploit them, and if you're willing to invest a lot of time in learning all this stuff, you can probably make some money. But yeah, of course it's difficult to tell. That's pretty much it for the questions. Also, if you like talking to people about interesting things like this, or working with people who like to hack on stuff, we're hiring. So if you are a software engineer, talk to me or anyone who is in the organization of the meetup, and then we can talk. And that's it.